So let's talk first about the North Atlantic Oscillation. It's to do with the westerlies, and it's to do with significant variations of the strength and pathway of the westerlies in the North Atlantic. Okay, so this one is a mode of interannual climate variability, like the ENSO in the Pacific Ocean, but in the North Atlantic it does not involve sea surface temperature anomalies at all. So the ocean is not linked or coupled with this instability. It's an atmosphere only instability. Okay, and there are two different phases. One is called the positive phase, one is called the negative phase. And these phases control a number of things, including the location of enhanced or reduced rainfall over Europe. Okay, and so that's one thing. Also, the magnitude of storms over the North Atlantic. This oscillation also determines how much ice and fresh water flows from the Arctic Ocean into the Greenland Sea, for example. Okay, it's good to know about this oscillation, and you can construct an index, an atmospheric index called the North Atlantic Oscillation Index, and it's based on the air pressure difference between Iceland and the Azores, and sort of to determine the strength of the westerlies. And sometimes the westerlies are stronger, sometimes they are weaker, and so on. You can construct this index. Okay, and this little graph here shows the time series actually from 1860, okay, until 2000, and you can see that there's an oscillation, that sometimes you have positive and sometimes you have the negative. Okay. In terms of the oceans, what it does influence is something that we call the spring bloom. The spring bloom in the ocean, because the storms actually lead to mixing in the ocean, and the mixing can actually create a fairly deep mixed layer and can delay the spring bloom development. So let's talk a little bit about the spring bloom. Okay? Here we are, the spring bloom in the North Atlantic. So what it is about is that during winter time we have a very deep mixed layer, convective mixed layer, mixed down to 1,000 meters. And what this does is it actually lifts nutrients into the euphotic zone. But there is no significant production of plankton in the euphotic zone during winter time, because the plankton spores are mixed over 1,000 meters. They spend only a little bit of time in the surface mixed layer in the euphotic. So now the action happens with high nutrient levels once stratification starts to form, density stratification. And this happens during the springtime, the warming period. You get stratification, and this traps the plankton production, traps it into the shallow surface mixed layer in the euphotic zone, and this creates a widespread plankton bloom in the North Atlantic, diatom bloom. And this is a little bit shown here in this time series. Okay, in springtime you have a big plankton bloom developing, and you can see it in satellite. Okay, you can see that widespread bloom. And something similar also happens in the Pacific. Okay, but not as pronounced as here. And then you get a delayed zooplankton. So the plankton bloom. So just to mention that once the nutrients are exhausted, the plankton bloom So by the beginning of summer, the plankton bloom is all gone, but you have the zooplankton bloom starting. And the zooplankton actually feeding on the phyton. In fall and autumn, you get a secondary plankton bloom, and this is to do with storms. Okay, the winter storms, which actually bring up nutrients into the euphotic zone through mixed layer deepening, through the stirring of the surface. Okay, and this is what we call the spring bloom, and this is very important to know about because it's one source of nutrients fueling plankton bloom. It's a significant feature in the North Atlantic. All right.